discuss the next problem. So let me first make the diagram. So we have a cylinder and there is a piston in the middle that divides the cylinder. Mass of the piston is m, so let us say this has a mass m. Cross-sectional area of the piston is s, so area of this piston is s. If you see in the 3 dimension, it will look something like this. So you have a cylinder and then you have a piston here. So the area of this piston is s and the mass is m. Now of course this piston is kept horizontal, not vertical. So piston and the cylinder system has been kept horizontal. Now let me write. This question says in a cylinder filled with ideal gas. So this cylinder contains ideal gas. So let us say both sides you have ideal gas. So I can apply now PV is equals to nRT equation if I need, and close from both ends. Now it says in equilibrium the piston divides the cylinder into 2 equal parts. So this part and this part are equal. Let us say volume of this side is V0. So volume of this side is also V0. Now the question says the gas pressure is also P0 both sides. Of course both sides should be equal pressure because this is frictionless, so it can move. So you must have force from this side is equals to force from this side. That is the both sides you should have same pressure. The piston was slightly displaced from equilibrium position and released. So what we are doing is, so this is the equilibrium position and now we are displacing this piston. So let us say if I displace right, there is no problem, I can displace right or left. So this is the initial situation of piston. Now if I displace right by a small distance, let us say this small distance is x. If I displace by a small distance x, now question says this will start doing a SHM, pistons to SHM. Find the oscillation frequency assuming that the process of gas is adiabatic, and this is also given that the process is adiabatic. So in this system the gases follow adiabatic process. Are you getting? So this process is adiabatic. Now you see you have to find time period for this oscillation. Now I will give you a hint how will you proceed. You see, once you move this piston this side, of course this side pressure will be decreased because volume has decreased. So this side you have less volume, you will have more pressure. This side you will have more volume, less pressure. This means now this side you will have a resultant force because this side pressure is less, this side pressure is more. So resultant force will be in this direction. So this piston, if you shift this piston this side, this will try to move this side, that is the mean position. So you just find this extra force and equate it to mass into acceleration. So I will give you some more hint. First find out the volume this side, pressure this side, pressure this side. Find out the difference in pressure and then write the equation. I will give you 1 minute time. I think some of you can do this one. And you can also use to find pressure PV gamma is equals to constant. You can use that one also. Okay, let us discuss. So what is the volume this side? So this volume, that is the extra volume, so if I displace this side and the piston area is A, so this volume is A into delta X. So I can say left side I will have volume, so left side volume will be, initial volume was V naught, now there is an increase in volume A into X, and area is given S. And right side you will have volume, so if you see right side, there is a decrease in volume, that is V naught minus S into X. Now I can find left side pressure, that the PV gamma is equals to constant. So let us say we find left side pressure. So how we'll find? We will find using the, let us call this as a P1. Left side pressure is P1. So I apply PV gamma is equals to constant. So initial pressure was P naught. Initial volume was V naught. This is gamma equals to constant. Now the new pressure is P1. Volume is V naught plus Sx to the power gamma. So this means P1 is equals to P naught and V naught divided by V naught plus Sx raised to the power gamma. Are you getting? Similarly, we can find right side pressure. Let us call this as a P2. So I will have right side pressure. Let us call this as equals to P2. So again I will apply PV gamma equals to constant. So P naught V naught to the power gamma is equals to P2. V2 is V naught minus Sx to the power gamma. This is equals to, so from here I can find P2. So P2 is P naught V naught by V naught minus Sx to the power gamma. So this is the P2. Now let us discuss the motion of this piston, because mass of the piston is given to you. So if I consider the motion of piston, what are the forces acting on the piston? So if you see, this is my piston. From this side there is a force, so this piston is basically displaced from distance x. So this distance is x. I think I can remove the top one. So from this side, from left side pressure is P1. You see your copy. So I can say from this side the force will be P1 into S. Right side there will be force will be P2 into S. So resultant force in this direction will be P2 minus P1 into S. And this should be equals to mass into acceleration, and this x is this side, the force is acting this side, so I have to apply a minus sign. Mass into acceleration, acceleration is d2x by dt square. And I know the value for P2, P1. You see the back, you have P2 and P1, so you can plug the value of P2. P2 is this, P1 is this. So if I plug the value of P2 and P1, so I will have P0 is common. I will have V0 divided by V0 minus Sx to the power gamma. This is P2 minus P1 is V0 divided by V0 plus Sx to the power gamma. Are you getting? I think P2 is this. So P2 minus P1. This is equals to minus m d2x by dt square. Now what I will do is, now I can apply approximation. So let us take V0 to the power gamma common. So we will have V0 to the power gamma if you take common, or I can do other way around. Okay, so let us do this. Let us divide by V0. So we will have 1 by 1 minus Sx by V0 to the power gamma minus 1 by 1 plus Sx by V0 to the power gamma. Are you getting? This is mass into acceleration, so this is minus m d2x by dt square. Now if you expand binomially, so let us say first let us write 1 minus Sx by V0 to the power minus gamma minus 1 plus Sx by v naught to the power gamma minus gamma. This is equals to minus m d2x by dt square. So now if I expand if I expand binomially, so I will have 1 minus x to the power n, that is 1 minus nx. So simply this will be 1 plus sx by v naught, and this will be minus 1, and this will be minus of sx by v naught, so minus minus plus sx by v naught. This is equals to minus m d2x by dt square. So we will have 1 goes out, so we will have p naught 2 p naught s by v naught m also into x. Let us put minus this side, d2x by dt square. Now this shows the simple harmonic motion with omega is equals to under root 2 p naught s by m v naught. So time period will be 2 pi by omega, where omega is given by this equation. Are you getting? So we have to find out the time period. Basically I have missed this gamma, so nx, so I will have gamma here. There is a gamma, so there is a gamma also. So this will be gamma, there will be, because 1 plus nx is equals to 1 plus x to the power n is 1 plus nx. So I have missed the gamma. One more mistake I have. So this is s. So this multiplied by s will be there. So this multiplied by s, this multiplied by s. So this will be s square everywhere. So let us say s here. So finally we'll have s square. So here also we will have s square. Are you getting? So here we will have s square. So I have missed this s. You see in the top, this multiplied by s. I have not written s here. So I have to multiply by s. Everywhere you multiply by s. So finally this will be 2s x into gamma. I have to s into s, so s square. So this will be s square into gamma. Final answer will also contain s square. Are you getting? If you want, you can take s common also, because this is s square. So if you take s common, so it will become omega is equals to s under root 2 p naught gamma by m b naught. So this is the omega. So time period will be 2 pi omega. Omega is given by s into under root 2 p naught gamma. M b naught goes on the top. So this will be the time period. Are you getting? We'll discuss the next problem. Now let us see what are the important points we have in this question is. This question is relates the concept of adiabatic process, SHM, and some ideal gas process. So you see what is happening if you displace the piston. One chamber of the cylinder will have lesser pressure, other chamber will have higher pressure. So this means if you press, now chamber will press the piston. Initially you have to press the piston. After that, equilibrium of chamber is displaced. One side will have higher pressure, so this piston, this will displace the chamber to the left side. Right piston will be displaced to the left side, and then left chamber will have different pressure. So now left chamber will press. So this will continue to the SHM motion. Now what is the difference? How to find the difference in pressure? For that, let us say one side pressure is P1, other side pressure is P2. Now pressure is related to the volume and the process is adiabatic, so I can always calculate pressure P1 and P2 both sides, and then I have to find the difference in pressure. And once I know the difference, I know the resultant force that is acting on the piston, and I can equate resultant force is equals to mass into acceleration. From there I can get the omega. So this is a simple problem. Only thing is you have to find out the P1, P2 in terms of exponent gamma, and then you have to equate mass into acceleration. We'll discuss the next problem.